Hello, welcome to our technical session, Non-Revenue Water Technologies. In this session, there will only be one presentation followed by a live Q&A section. The presentation today is entitled The Benefits of NB-IoT, which is Narrowband Information of Things, for Non-Revenue Water Reduction Implementation. My name is Karlene Singh, and I'm the Business Development Project Engineer at Consolidated Water Company, which is headquartered in Grand Cayman, where I've been for the last 15 years. First of all, I'd like to give a warm thank you to our conference sponsors. We truly appreciate the support of Sandpick Contracting Cayman Limited, Deal Metering, Mia Water, Water Engineering and Pipeline Company Limited, or WEPCO, Consolidated Water Company Limited, DART Enterprises Limited, Florida Aquastore, and Argo American. Before we get started on the session, I'd really like to just briefly review a few items. You'd have the opportunity to submit text questions at any time using the Q&A section on the Hoover app, and questions will be answered during a live Q&A immediately after the presentation. And it will be a collaborative session where everybody in attendance will be able to participate and engage in the discussion during that live Q&A. So now I'm pleased to introduce our speaker, Mr. Paul Fanner. Welcome, Paul. Paul is a chartered UK civil engineer and a leading non-revenue water expert with broadband experience gained over 43 years in the industry. He has extensive water utility experience from working for both Thames Water and Bristol Water in a wide range of roles. Paul also has an extensive international experience, having worked in Nigeria, India, Malaysia, Trinidad and Tobago, Russia, Vietnam, Philippines, Barbados, the USA, Bahamas, Jamaica, and Canada. Since 2001, he has worked full-time as an international consultant specializing in NRW reduction. Paul is currently working as a project director for MIA on Caribbean performance-based NRW reduction projects in the Bahamas and Jamaica. He is also leading a project to develop the NRW reduction strategy for the City of Toronto. Paul is a fellow of the IWA, member of the IWA Water Loss Specialist Group, and regional representative for the WSG for the Caribbean and Central America. Paul, I'll now hand it over to you. You may start your presentation.
Thank you very much, Karlene, for the introduction. Good afternoon, ladies and gentlemen. I want to use this session to talk about the benefits of narrowband Internet of Things, which is a new technology which can help with reducing the problems of implementing a non-revenue water reduction implementation program. So what I want to cover, in this presentation is to start with looking at the current status of NRW in the Caribbean, look at the data requirements for reducing NRW, consider the various available telemetry options, and draw some conclusions. Sorry, the slide isn't moving. Okay. The move it's very slow to change slides. So to start with, looking at current levels of non-revenue water in the Caribbean. Back in 2019, Roland Limburger and Alan Wyatt updated their world estimates of non-revenue water, and Latin America and the Caribbean came out to be pretty high in terms of cubic meters per day, the highest of any region, and in terms of liters per capita per day, second only to Central Asia. Looking at the Caribbean, obviously there's quite a bit of NRW variation between the islands. This slide is again based on the data that Roland and Alan put together. And as you can see on the left-hand side, we have some very high levels of NRW. The dark blue bars are representing the volumes of NRW as measured in terms of litres per connection per day. But all those countries that have got a red circle around them have intermittent water supplies. If we take account of what the NRW would be like if they were actually supplying water 24 hours a day, we get the lighter blue bars in terms of litres per connection per day when the system is pressurized. And as you can see, we have some extremely high volumes of NRW in the islands. We've also got significant impacts of climate change in the Caribbean. 7 Caribbean countries have already been identified by the Water Resources Division of the United Nations as having extremely high levels of water stress. Caribbean water resources are suffering badly from climate change, which is resulting in hotter, drier summers, extreme variability in rainfall, with reduced rainfall, which is creating more frequent and more intense droughts, but also more intense storms and hurricanes, leading to very heavy rains and flash flooding. But unfortunately, those very heavy rains don't necessarily help that much with improving water resources. The rising sea levels are creating increases in saline intrusion, all of which is reducing the raw water quality, and as a result, the existing water resources have reduced capacity. We're also seeing, as a result of climate change, an increase in intermittent water supplies, and I'll talk about the problems of those in a minute, but they're very bad news. And most of the islands have run out of traditional new water resource availability. There's limited availability, and if it's available to develop, it's costly. For a lot of the islands, reverse osmosis water resources are becoming the only solution for new water resources. And RO, while it provides an excellent resource, has a much higher marginal cost of production than the existing resources. So this provides more incentive to reduce the need for new resources by managing the networks better. High levels of NRW for the water utilities result in high operating costs, poor customer service, loss of revenues, and the growth of intermittent water supplies lead to a spiral of decline, because every time the system's charged, the pressure transients created cause more breaks and leaks in the system. But at the same time, undertaking leak detection in those networks is very difficult, because when the supply is on, all you're hearing is the sound of tanks filling. So very difficult to find and fix the unreported leaks that are created by intermittent supplies. So as a result, you see increasing NRW in intermittent supply systems. So what's the solution? Well, Caribbean water utilities, particularly those on the left-hand side of the earlier chart, must take effective action to reduce NRW and stop the cycle of decline, and thereby improve the utility finances and customer service. And sustainable NRW reduction is extremely cost effective. It enables utilities to use the existing water resources more efficiently, eliminate intermittent supplies, improve customer service, have surplus water to meet new demands, and thereby defer the need for new expensive water resources. Now, in our experience, the majority of non-revenue water is always due to physical losses. The split between physical and apparent losses or commercial losses varies from island to island, but it's almost always the majority is of physical losses. So the NRW reduction strategy must effectively reduce physical losses sustainably. So what do we need in terms of data to do that? Well, if you can't measure it, you can't manage it. And in order to effectively reduce physical losses sustainably, you need a lot of time series data. You need system input volumes, the flows into and out of the pressure zones and the district metered areas, the pressures in and out of PRVs. You need the control of the PRVs through controllers, critical point pressures, particularly in PRV controlled system, and average zone pressures in DMAs. You also need storage tank levels or inlet and outlet flows from tanks in order to take account of changing storage in the tanks. And ideally, you would also log particularly large customer consumptions, because they can very easily distort the minimum night flow picture if you don't know what your larger customers are doing. And newer technologies like leak noise correlators and correlating leak noise loggers also need to send noise data across the network, which is quite data hungry. So a lot of data that needs to be collected. Now, Caribbean distribution networks are typically have fairly high break rates, high rates of reoccurrence of leakage. And in this situation, you really need very small DMAs in order to focus leak detection on the problem areas and enable you to keep losses low. And if they're small DMAs, that means you have a lot of DMAs. You end up with many data collection points, typically in the hundreds. And they're distributed throughout the distribution network, mainly in locations with no power supply. Now, in terms of data communication requirements, we don't need real-time data in order to manage physical loss reduction. It's good enough to receive the data once a day, ideally best early in the morning, to enable you to get a daily assessment of non-revenue water in each DMA and look at the previous minimum night flow. So, you don't need to be looking at real-time data, but it is important that the data communications are reliable. In terms of data resolution, historically, everybody was using 15-minute average data. This originally came from UK practice back in the days when data loggers had limited storage on them, and the data communications bandwidths were much lower. These days, we certainly would recommend using higher resolution data. For example, 1-minute average data, which gives a much better insight into the reasons for variations in trends in pressures and flows, and enables you to focus on what's causing particular problems. And for pressure loggers, the ability to switch from normal 1-minute average logging into very high frequency logging to record damaging pressure transients is also very useful. Pressure transients are one of the key causes of breaks in the network, and if you can identify them, pin down what's causing them, then you can put in solutions to remove them. So what are our telemetry options? Well, if money is no object, SCADA systems are good. They provide real-time data. As we've said, we don't really need real-time data. SCADA can be useful for the system input meters, which are key to assessing the overall top-down NRW in a system. because then you can immediately identify any failure of the system flow logging and then sort it out. You don't want to lose that data. But telemetry loggers can be configured with alarms to provide any information on loss of flow data. It's the most expensive solution, and as well as the RTUs, you also need to include budget provision for housing the RTUs in environmental cabinets, IP68 cabinets, and providing power to each RTU using either solar or supply from street lighting, whatever. Not really practical for most utilities, although one or two utilities in North America have used SCADA in their networks. Most systems over the last 20-25 years have been put in using conventional cellular data loggers, using either 2G, 3G, or 4G cellular modems. There are much cheaper solutions than SCADA RTUs. They're fully standalone with built-in lithium batteries, and they're already environmentally protected to IP68, so you can put them into chambers that flood and expect them to continue to operate. And for those reasons, they've been the main technology chosen to support NRW reduction projects for many years. But there are some problems with these conventional data loggers, which I'll go through briefly. Firstly, the network. The network is not owned by the utility, and the utility has no control over the network operators. Networks were put in primarily to support mobile phone technologies, and the network operators are continually upgrading the technology to satisfy the ever-growing needs of more sophisticated phones. So, networks are being upgraded from 4G to 5G at the moment. Data loggers that were using older technologies can be rendered obsolete when network operators decide to switch off the old technology standards. So certainly a lot of 2G networks are being phased out. Some 3G networks are starting to be phased out. And that means you have to replace your data loggers unless they have a modem card which can be replaced, and a lot of them don't. The logger manufacturers are also reluctant to support the latest technology because each new cellular technology requires more battery power, and battery power in standalone data loggers is a premium. So they tend to stick with the previous technology as long as they can before they upgrade to the next technology. Data communication from chambers is often poor, so it's often necessary to install data loggers in an above ground telemetry pillar, or install an external antenna to get the signal out. And where you have poor data connections, they can create very high battery drain because the loggers continually trying to communicate. And battery replacements become quickly required. But shipping of lithium batteries is a real problem. There's very few air carriers that will ship a lithium battery that's not in a piece of equipment, and that makes getting the lithium batteries expensive. And finally, the data communication costs associated with the mobile phone cellular data technologies are quite high. So a new communication standard was in 2016 called the Narrowband Internet of Things, NB-IoT. It's a standards-based low-power wide area network technology, and it was developed to enable wide range of new Internet of Things devices and services, really to support the development of smart cities. And this new communication standard has been rapidly adopted across the world. NB-IoT networks are now operational with 158 network operators in 83 countries. But unfortunately, as of yet, I don't believe there's any operational in the Caribbean. And because of the rapid adoption of this technology, several of the data logger manufacturers, the noise logger manufacturers, and the PRV controllers are now available with NB-IoT versions. And those new technologies provide considerable benefits over the mobile phone cellular technologies. These are the main benefits of NB-IoT data loggers. They can considerably lower power consumption. To give you an idea, 5 to 10 times less than 3G, 4G data communications, which means that you can have a much longer battery life and not worry about having to ship expensive lithium batteries. The technology is designed to access equipment in underground locations, significantly improved underground coverage, which in most cases will mean no need for telemetry pillars or external antennas. And the communication costs for this data are much lower than the communication costs from normal mobile phone technologies. And most importantly, it separates the NRW communication technologies from mobile phone communication technologies, which means that your NRW equipment won't become obsolete when the next mobile phone upgrade happens. So you get overall lower cost of ownership and operation, much better technology to support NRW reduction projects. So to conclude, Caribbean water utilities with high levels of NRW really must take effective action to reduce NRW. And sustainable NRW reduction is extremely cost effective. Most NRW reduction programs pay for themselves within the timescale of the program. NB-IoT data loggers, PRV controllers, and leak noise loggers offer much better communication technology to support NRW reduction projects and will reduce the technology costs of implementing NRW reduction programs. So we think that Caribbean water utilities should lobby the cellular operators and their governments for the introduction of operational NB-IoT networks in the Caribbean. That concludes my presentation. I'm happy to take questions.
Good afternoon, all. Thank you very much, Paul, for that very interesting session. I'd like to invite Paul he can turn his camera on now as well. And we are able to take your questions. Anyone who has any questions, you could please enter it in the chat section. So the first question that has come in, Paul, the first question asked is, what are the possibilities to upgrade the data loggers from 2G to 4G?
Thank you, Karlene. Thanks for that question. It depends on the particular make of or model of logger. It used to be none of the old logger technologies could be upgraded at all. More recently, some of the manufacturers have made available the ability to replace the modem card to upgrade to the later technologies. But you would need to talk to your logger manufacturer to see whether that's an option for you.
Okay, thanks very much for that. I have a couple of general questions until some others come in. You mentioned that 83 countries right now have implemented NB-IoT. I was wondering if any of those are other small islands similar to the Caribbean And I guess what sort of infrastructure is needed? Is it significant investment in infrastructure for local governments? Or if you could elaborate on that a little bit, that'd be great.
Yeah, the technology sort of piggybacks onto the existing cellular technology infrastructure, so you can use the same masts as we've got for 2G, 3G, 4G communications, and it is relatively inexpensive for network operators to introduce the NB-IoT facility. In terms of the countries that currently are operating it, it tends to be the more developed countries, so North America, Europe, Asia. There's a lot of networks operating. I'm not aware of whether there's any in small islands, but even the Caribbean islands, once this technology is available, it wouldn't just be available for use by water utilities to do NRW projects. It would enable you to utilize it for a whole host of smart city improvements. For instance, it might provide a lower cost option for you to put in automated meter reading for not just water, but gas, electricity, etc. So there are benefits to the countries for putting this technology in, and I think that the problem is that nobody's been really pushing for it at the moment. So that's why I'm suggesting that we need to start lobbying.
Okay. Thank you very much. We just have about 3 more minutes for questions. If there are any other ones coming in, I have one I could wait until any other questions come in. Let me just make sure. Oh, sorry, there were 2 more here. Okay, so another question that came in. If water utilities are to lobby network operators to support NB-IoT, what would be the best way to convince them? In other words, what is in it for them?
From the water utility customer demand is probably not going to be attractive in itself to network operators. That's why I think that it probably needs to be more through the governments to who looking at a wider picture of moving towards more smart city technologies, as well as this particular technology to implement them. For the network operators to move water utilities to this technology, they would actually be losing income from the current 2G, 3G technologies. So it needs to be pushed by governments really to make it happen.
Okay, thanks very much. And just for our last couple of minutes here, we have one other question. What is the difference between the IWA and the AWWA water balance, and which one can we use? It says P's. Is there an upgrade version 6? I'm assuming that's it.
There's very little difference between the two. The American version has made very minor changes to the IWA water balance, and to be honest, it doesn't matter which one you use. They're both good as long as you're able to quantify and put into one of the components, the water balance, every drop of water, and get away from the unaccounted for water that we used to talk about. Then either will work. And certainly in the Caribbean, we're using the IWA water balances with no problem at all.
Okay, thank you very much, Paul. So we're actually right on time to end this session. We just want to thank all of our attendees for joining in, for the great questions that came in, for your time, Paul, for sharing this with us. Again, we'd like to thank all of our sponsors, and we ask everyone to join in again for our technical sessions coming up later in the day. All right, so thank you all again.
Thank you all too.